Good evening, everyone. We are going to be discussing methodologies, specifically for custom software development. On occasion, we have to customize software or write specialized software. So we'll talk a little bit about that. Predominantly these days, we use package software for many business applications. We've discussed cloud-based apps and even client-server apps. Um, but occasionally, and on many or certain instances, we would have the need to customize software or do some custom development. So we'll be discussing a bit about that and um, some methodologies and tips around how to do that best and some best practices. And then finally, for any system, as we've been discussing, we have to do a complete job and a thorough job on requirements gathering and many times business process requirements definition or redefinition. So we'll touch on that in today's session. Like we've been discussing, it is generally better to buy or purchase software packages whenever feasible. Either you purchase them or you rent them on the cloud. Um, Occasionally, you have to go into custom software development. There are several different types of methods that we will discuss around customization of software. And the widely accepted systems development lifecycle is the traditional method of design, build, test, and run. You have some prototyping techniques that are often used to expedite in the front end of that process. You have RAD or rapid application and agile development methodologies that we're going to touch on. So these are the four. There are different hybrid versions of these. As you can imagine, in real life, there's maybe more than one of these techniques that are used in conjunction. So first and foremost, systems development lifecycle. This is the traditional, highly structured process of developing software. This requires specificity, documentation, formalized reviews. This is basically how we used to do things in the mainframe days, in the early client-server days. We still use this. This is a widely adopted technique. A lot of people don't like it. A lot of customers don't like it. Clients don't like it because it is often elongated and has a lot of cycles before you can see results. And so traditionally, this is known as the waterfall method as well, where you can see first you define, and until you define, you don't go to the next step, which is construction. And until you construct, you don't really go to the next step until, which is implementation. So it's got this waterfall nature behind it. Now, if we decompose these, each step of the waterfall, you'll find that there are some key activities that I just want to touch on. In the definition phase, one of the things we focus on first typically is feasibility. There's a study done usually before you embark and even budget for the rest of the project around how feasible is this system. Do we have the technical capability? Do we have the technical tools? Do we have the technical skills? Do we understand what we need to do? Do we understand the commitment of resources that are going to need it? Is the organizational ready? There's a series of aspects around feasibility, and the outcome is it is either feasible or it is not feasible, or it is feasible with certain readiness criteria that have to be met. After the feasible study, we typically go into requirements, which is collection of how-tos. What is required? When is it required? What is the benefit? And I like to see each of these aspects of requirement definition tie back to a business case. Typically, a business case was built before you entered into the software delivery lifecycle or before you commenced this process. And it's always nice, and I always look and challenge my teams to um, tie back every detail requirement, whether it's a system requirement, a functional requirement, a bell and whistle, whatever it is, a report, tie it back to the value of the system, right? Or the business case that was built. And if you can't tie it, then you kind of know that the requirement that a set of users is providing towards the system may not be necessary or may not be a priority. And anyway, it's a good check. Um, Assuming you get the feasibility and requirement studies done, you move into construction, and typically I like to have a toll gate there, which is you check and see if the business case is still valid, that the work that's been done so far ties to the business case, and that we have sign-offs from the necessary stakeholders before we go further down the line. And typically, I like those toll gates to be rather strict, and oftentimes I would insist on executive involvement. But otherwise, you want to make sure really that you have sponsorship from the business side, from the technology or the CIO, or whoever is responsible for the overall success of the project. Um, Assuming you have that, you move into construction. Design is the detail of how things are going to work. So the requirements could be the what, the design is the how. Fairly detailed level of specificity, enough for a programmer or a systems implementer or a systems integrator to implement the solution. Um, After design is complete, you go into the system build, which is typically either some set of programs or some set of heavy customizations to existing code, etc. And once the checks and balances have matched and the tested and it's unit tested, we move into system testing, which is bringing all the integrated components together, bringing the business processes together, and actually seeing if this thing works as designed and as required, right? And after that, you have another toll gate. Assuming you pass the toll gate check, you go to implementation, which involves a whole set of other activities, which is actually implementing or installing the system or putting it into production, I call it. Um, you would have a lot of operational considerations. Okay, how is the system going to work? What is the staff necessary? What are the technical and non-technical people required? Of course, all of these steps could have been pre-planned, but you have to now start to execute them, right? And maintenance is how are you going to, and what are the steps, or is a structure in place to actually make the system living and breathing and running on an ongoing basis, right? Of course, there's training, there's change management, all of those things to make the implementation successful, right? Measurements, metrics, tying back to the business case, of course, all of that, right? And typically you go through this, this could be, I've seen this take upwards of, 3 to 5 years to complete a very, very large project. Oftentimes you have some projects that complete 6 months to a year. I'd say full delivery delivery life cycle waterfall. I haven't seen them for shorter projects in the recent times because there's other better ways of doing shorter projects that we're going to talk about in a minute. There's another critical way that we can hybrid into the SDLC is using prototyping technique. And prototyping technique is just like the name sounds. It is actually testing the system in a small environment, right? In a little bit of a risk-free environment to see if we can make the system work on the fly and get people excited and sort of prove out that the system can serve the needs. So you identify the basic requirements, you develop this prototype based on very basic requirements, you use the prototype and start to change it. Of course, this is very suitable for smaller efforts, smaller to mid-size efforts. You revise it maybe 1 or 2 times. more new requirements come in, you keep them kind of contained and managed, then you evaluate it as an operating system. You start to prove it out. You don't, it's not the end system, it's the proof of concept, if you will, or prototype. And after you make the changes, if folks feel like it's going to work, you move ahead with the full life cycle project or some other way of embellishing upon this, or you abandon it, right? The prototype has served its need. You've made a decision really quickly. And of course, if you do decide to implement it, you would install, operate, and maintain, and go through the steps that we discussed earlier. Now, all of this needs a good project team, right? Typically, the project team is a bunch of information systems professionals who can quickly build systems. They could be internal folks, they could be consultants, they could be a hybrid team, they could be onshore, offshore, what have you. And then you have typically business users who are committed to working closely with that team. And they'll try out different things, refine the prototype, and so on. Very large advantages to doing a prototype, right? Front-end requirements are easy to ascertain. That's what the client usually sees, or customers usually see, so it's easy for them to articulate that. Typically, this is used to develop systems or show how things are changing, particularly when there's a bigger, more disruptive or radical change. It also allows firms to explore uses of new technology to see if it works in their environment. It could be available to test very quickly by users. Less of a larger commitment is needed. Of course, if the prototype turns into a production-ready system, you might need something more. And you can also get better costs and better benefit realization, or better benefits understanding after you experience that initial prototype. So it is a very common technique that's used because of all of its benefits, right? And these cannot be underscored enough. Of course, there's some disadvantage to using the prototype method. You've got lack of security. Usually, it's not a complete system. Many clients start to think and fall in love with it as if it was a complete system, so it becomes hard to explain why more work is needed to be done to actually make it production ready. Typically, it's scrappy. Just cobble it together in a conference room. You might hear about a term called conference room pilot. That's what that means. So, it's the scrappiness, while it's good, might be misconstrued by many environments if they're not used to it, to say that, okay, this is not really a full-fledged system. So sometimes it's hard to manage expectations. I know that's happened to me several times when I was working with IBM. Just to give you an example, there was a reporting system that we were asked to write, and the requirements were fairly complex. People couldn't define them as easy, so we came up with this prototyping technique. And we were able to build a small tool with some sample reports, and we could show them how easy it was to build a report. Well, the users thought these sales reports were really easy to build, so they started giving us more requirements as they saw the sales report, but the data and the infrastructure didn't exist to get those reports, and that's where the bulk of the work was, which was different from the big system that ultimately would needed to get built versus the prototype. So it was a little difficult for us to explain and justify to non-technical people why it was going to take another 6 months to bring all that data in and to make it production ready, make the report secure, make the reports printable in PDF and in other formats, password protect the reports, automatically deliver the reports automatically in an email. All this required workflow, and it was well beyond the scope of the prototype, but it became hard for us to explain. So that's an example. Of course, we got over that aspect of it, but these are things that come up in the prototype. Now, you can use, of course, this prototyping technique with the SDLC full life cycle methodology that I explained before. You would just add another step or replace the requirements with prototyping up front, and then the detailed requirements can follow, for instance. And very often these are used for screen designs and wireframing and things like that. You can also use it as a pilot strategy, build a working prototype before the construction for a small set of users or some sort of segment of your entire population. Um, Rapid application development, or RAD for short, is a hybrid methodology, combines the best of SDLC and prototyping. And of course, the goal being producing a system more quickly than SDLC alone. SDLC alone involves documentation, writing. Users have to wait a long time before they actually see a system visually. Prototyping, blending that in helps that gap, helps fill that gap, or give uh, a picture, a usable picture, working system to play with or to sample. And it works quite well. I think prototyping is a great way to secure more investment from the company without, fully completing the project or without going really far. Sometimes companies do not want to invest until they see something tangible. Prototyping is a great way to reassure your clients or internally that there's hope for the system, there's a lot of promise, and therefore it can secure funding quicker. This concept of joint application development, or JAD, basically is a team of users and technologists that get together and work through an intense life cycle to come up with uh, gathering information and requirements in a very short period of time. So typically JAD sessions are done in like boot camp style. You get together for a week or two and you develop really the requirements together and in one shot rather than going back and forth. We did that at the Marsh McLennan implementation of Salesforce in the late 2000s. I think 2000, no, just 2012 or so, 2013, maybe about 6 or 7 years ago, to roll out that large system on 50,000 users. To get requirements organically would have taken 2 years. So we got all the leaders from all the geographies, booked a hotel conference room, sat in, facilitated a session, had Accenture, myself, facilitate those, and draw out requirements literally in a week and spit it back at them or review it back with them to get concurrence. And that's how we built the shell, requirement shell for a 50,000 40 country implementation, because we had everybody, the experts from different geographies, to come in and work through the session. And it worked quite well, actually. It's very hard to organize, slightly expensive because we had to, fly people in, but it definitely cut down the development time. And like I said, cut down the development time. It's right on the slide that I plan to share with you, which was, generally these type of techniques could increase costs. It could cause people to stop working and doing their day jobs for a little bit, but it can then really dramatically improve the cycle time or the development time for the system. And it's quite rapid, and that's why the name suggests rapid. And we also set up a change control process so that we have a good ability to replace or add to the system requirements based on requests. Oftentimes people miss a few things, right? In the spirit of getting everybody together, getting agreement, getting shortcutting, sometimes certain quality aspects might be sacrificed. But I think any of those can be overcome by adding a healthy check and balance throughout the project. I mean, requirements will change. You just have to have a nimble process where you can get approvals quickly and you can expend or include those requirements in the system. So it's not for everybody, but it works, and I've used it on several occasions. The Marsh example was one of them. There have been many But then there's also been systems, especially in my days at IBM, where we did not do this. We had everything buttoned down, and then we gave it to a team that used to sit in Montana at that time. This is before India offshore really took place for IBM. But Montana and other areas, actually Fishkill, New York, and um, Poughkeepsie, New York, where our development centers were. We would just package up all the requirements, get it approved at headquarters, and then ship it over there and wait 6 months until the system was built. And, that worked too. It just took a long time. But it definitely does work. And certain use cases warrant that kind of implementation, especially when systems are more complex and mission critical. They're often done, the old fashioned way. You might have heard of agile development. We use Scrum-based, which is a well-orchestrated movement of team members that work together. It's kind of like a rugby game where there's independent teams. Then there's a lot of coordination and communication. It's iterative, highly iterative, highly self-sufficient, and efficient also, using tools and spreadsheets and a lot of quick and dirty collection exercises. And they have these things called sprints, where they go and they work on requirements real quick, show the system being built, then go back in, do what they call a playback or a sprint review, and have maybe 2 or 3 or 4 sprints before they can finalize the requirements. So people start to see results very quickly. People work together. It's very collaborative. Kind of sometimes hard because you don't know when the project is going to finish. Oftentimes it tends to have overruns. It's very hard to contain. If the users are used to giving requirements at every sprint, how do you really set the expectation that they can't give any requirements after a certain number of sprints, right? Sometimes it could be challenging, but then normally we do Agile or Scrum training. We have Scrum certified Scrum masters incubating the teams so that they can guide the teams properly and so on. Outsourcing is an alternative, right, for development. It is wonderful for application maintenance. It's also used for the core development of the applications, support, network operations. Increasingly, we see a lot of stuff going outside the walls of the company and being done by a third party. Cheaper, more effective. You don't have to manage the people, etc. There's this concept of onshore outsourcing and offshore outsourcing. Well, what is that? Onshore is contracting with companies within the same country, right? Same region. Offshore is over the fence, right? Over the ocean, over the shore, so to speak. Different countries. India comes to mind. Philippines come to mind. Mexico comes to mind, etc. Obviously, offshore costs could be very cheap because of the labor arbitrage, but there are risks. There's language, cultural barriers. Like today, I thought I was going to get something done from my India team. Now, I, being of Indian origin, should have known that it's an Indian holiday today. So I relied on the team thinking they were going to do something. I forgot that it was a holiday. It's not a holiday in the US. Shame on me. It's actually on my calendar too that my team was going to be off. But like an idiot, I called one of those guys and they said, "Oh, we're happy to help you because I'm their boss. They'll help me." And later I realized, well, it probably could have waited until tomorrow because I just bothered, my lead over there on his day off, and that was just my faux pas. But anyway, there's time and place for all of these and reasons for them, of course. Typically, companies outsource because they do not have the skills or do not want to foster or develop those skills in-house. It also is a great way to temporarily expand capacity of key resources. It frees up internal resources to do more strategic or more proprietary work. Lots of advantages along those lines. Lower labor costs and also availability of resources. I love the fact that I work with my India team. and that when I'm sleeping here, they're doing something for me, and I can see something back in the morning or what have you. And clients love that attribute when it works right. Okay. Some best practices around outsourcing are managing expectations, right? It's very difficult to manage people when you're not next to them, so you have to manage expectations. You got to be very clear on when things need to be done, why, give them a reason, um, take explicit actions to integrate teams from onshore to offshore. Lots of communication needs. It's always better to over communicate than under communicate. Manage things like a project, not tasks, because every task might have a different way of doing things or different time frame. So typically, setting up a project office or some sort of centralized control, you try things in a small way, then you expand, of course, and fix the kinks. And you might need legal help, and especially if you're contracting overseas and things like that. You've got to put technology in place to enhance the communication. We use right now at Oracle, we use Slack, we use other instant messaging, we use, of course, email. We have a variety of platforms to keep connected with teams that are not physically with us in the same location. And then, of course, now with the COVID environment and everybody working remotely, pretty much everything is sort of either onshore outsourcing or offshore outsourcing, because we're always working remotely by definition in today's environment. There are risks, and oftentimes users develop applications versus information systems or IT departments. And why do they do that? Because they sometimes can't wait, or they have some technical people, or they have some budget of their own and they can't squeeze into the corporate IT budget, what have you. But I call these sometimes renegade projects, run by small user communities. They could have pretty devastating results. I know at Marsh we had a bunch of people doing rogue stuff in different geographies, and we could, and it worked. But when that person left, we lost the skills, we lost the experience, we did not know how to train, and the system just died, right? And sometimes these are critical systems. Oftentimes the systems get heavily complex and they hit a roadblock and they need IT's help, and IT can't help because the system isn't certified or the system isn't passed a security check or what have you. And there's a slew of risks, but obviously user developed systems do exist out there. And I considered them another way of sort of outsourcing, either by necessity or by design. But typically, I have not seen good results when it doesn't get controlled or orchestrated by an overall IT umbrella. I find that those user systems actually propagate when there is less trust in IT, right? Okay, switching gears to the definition and construction phases of a project, there are some very important questions or considerations that must be asked, right? Obviously, input, outputs, what are the processes necessary, right? What are we trying to systemize, if you will? What should the system be able to do? Where is the data going to come from? Do you have data? How accurate, reliable, complete is the data? Very often systems fall apart here, right? That you might build a perfect system. It's not going to do diddly for your company unless the data supplied to it or in it or from it is reliable, right? And then you have to ask, well, where is the data going to be stored? How is it organized? Who's going to maintain the data? And so on and so forth, right? So, and many environments have regulatory requirements. So there's audit required, like in the insurance industry. I used to support them from a systems standpoint, and we needed a lot of audit trails built into the system. So a lot of considerations there. You got to make sure you leave enough time for testing, though, right? I cannot overemphasize the need to do adequate testing. Very often, clients and companies shortcut the testing area, and then we are back to where we started. And also documentation, so that the guys who maintain the system know what they're getting into, understand how the system is working, and so on. Other things that I've learned over time from users and developers is you've got to stay in touch with the folks that provided the requirements in the first place. I call them users. They could be anyone that has given you requirements. Got to make sure those requirements were accurate. Sometimes the users will give you requirements, and later when you design or you test or you build and test, you start to realize, geez, these doesn't make any sense. You validate, and that means you stay in close contact with the users throughout the life cycle of the project. Prototyping uncovers a lot of this stuff, right? That's why I love using prototyping, but it's still, the problem still can happen, right? Many times bugs and issues show up much, much later, and you have to keep the development methodology flexible so that you can accommodate, because at the end of the day, you want the system to be successful. If it has to change or it wasn't specified correctly, all best efforts should be made to keep, of course, the system on time, on budget, but also to deliver on the requirements. So all of this happens in a nutshell with this last bullet on the slide: managing expectations, right? Testing earlier, testing frequently, testing assumptions, not only the system, testing the business assumption, testing the business case for the system, right? All of these things, checks and balances, happen when the communication's open and there's good discussion and good, healthy conversation between IT, business, and if there's a systems integrator or some other third party involved, or more than one third party involved, there should be a good governance process. And I think that's one of the key areas or ways to make sure that these projects are successful. Now, shifting gears for just a second on system requirements, right? So how do you collect system requirements? Well, there's a couple of things on the full life cycle methodology that should be brought out, right? You have to determine the requirements, and then you have to structure the requirements, right? What do I mean by that? Well, requirements determination are, okay, what does the system need to do? And requirement structuring was how does it need to do it in terms of what business process modifications or business process accommodations will the systems need, right? And this is all in this analysis bucket. And I'm not going to drill down all of the detailed ways of collecting requirements. I just want to give some information and some guidance to you about why requirements definition is so important, and also the nuances behind it. So some of the key deliverables for requirements determination are outcomes from interviews, right? You collect information from conversations and observation, right? You provide good transcripts. You write up the interviews and the outcome from those observations, as well as the discussions. You then assimilate information about the business, like the mission, the strategic direction, reports that are needed, procedures, job descriptions. All of these help you determine requirements. You start to validate what the users are saying and what you know about the role. And there are going to be disconnects, and then you match up the disconnects and you discuss it, and you sort of put your best foot forward in terms of your understanding. And requirements is all about collecting and then sort of conveying it back to users for sign-off. And there's a lot of different techniques. JAD sessions, which are the joint design sessions we talked about, prototyping results. There's many techniques where you can just net out those requirements and basically replay it back for the users to make sure you got it correctly. So interviews, looking at existing systems, right? Observing workers do a day in the life of, right? I remember walking down the halls in a call center to see how the call centers are working at a client I had in downtown Manhattan about 5 years ago. We talked to different call center reps because our project was to really simplify the call center operations and create a new system and a new set of processes in a unionized shop. So we went and visited the call centers, sat in on a few calls of different types to ascertain the requirements. Um, these are some methods of gaining those requirements, right? Obviously, guidelines for interviewing is you got to listen, you got to prepare a nice agenda, don't waste people's times, and seek views from a diverse set of users, right? Active listening, interview skills are really important. Use open-ended questions, use closed-ended questions, use a combination. Many clients or many shops have a guideline or sometimes a discovery toolkit that they've prepared that they can enable. Sometimes as a questionnaire or an outline of an interview. There's many things available from PMI. There's many things available on the internet. You got to have a method to the madness, right? And it's not just free form interviews. Setting expectations and making sure that as you're interviewing these people, you're not promising them results. You're not, because the interviews have to be put together, the results have to be put together to combine all of the inputs into what I would call a requirements specification. So many times users in an interview will ask, well, am I going to get this? And you might feel like you have to say no or yes, but resist the temptation of either. Your viewpoint should be that you're collecting requirements, and then there's going to be an analysis of that requirement to see what's best to meet the objective of the system that's being designed. Sometimes interviews make sense in a group, sometimes they don't. Just depends, it's very situational. Individual interviews sometimes results in contradictions. You may have to go back. Sometimes I like the grouping techniques so that it's more effective and allows synergies and allows people to hear for what one people are doing. They can feed off of each other. Many times you can't make that happen. There's a variety of reasons, political reasons, there's a scheduling reasons, what have you. But these are common ways of getting people together. Nominal group technique or NGT is a process that supports idea generation, right? At the beginning of the process, group members generate ideas, and then you start to group those ideas. I like to use Post-it notes on a wall board, and it's a great interactive way and a fun way to collect requirements. Observation, as I mentioned, is another way. I did that in the call center example. It worked pretty well. I'm not sure I could have done it any other way, but sometimes it's a combination of all these. The easiest is the analyzing of procedures and other documents. Typically, I'll get some of my more junior folks on the team, maybe analysts, to review procedures and policies and see what we can gather that might be important in the system design that maybe people haven't told us or conveyed to us, or there's an extra level of detail. So that's another source of requirements. I think this just adds a level of formality, essentially, right? That maybe people just don't remember or are sophisticated to convey in an interview. So I'm not going to drill down an example of a procedure, but this is one that is titled Guide for Preparation of Invention Disclosure, right? So a system or this process in this example is to keep track of perhaps innovative ideas, and there are some rules of the road or rules of engagement that they have. It might be useful to read this and see how it impacts the system in terms of what the system needs to do or should do, but can't today, needs to be modified, and so on to meet the requirement. This could be, in fact, this is very similar to my first system I ever wrote out of college. I remember finding a client, it was a trucking company, and he wanted me to build an invoicing system, right? And I remember I coded that from Microsoft Access, and the first thing I told him is, show me what you want. And he showed me an invoice that looks very much like this with his data on it. And he said, this is what I want. These are the I want these. I have to print 100 of these out a month, and I don't have time to type them up. So I want a system that keeps track of all my inputs during the week, and at the end of the week, I can hit the print button and invoices come out. And so sure enough, in 3 or 4 weeks, I built him a system that did that. He paid me a good sum of money back then. And so sometimes artifacts are given, like invoices, like reports, like screen designs, like, users will be very creative on showing you stuff. They might whiteboard something, or they just might give you an invoice that looks like this, and you go make it happen, basically. Likewise, there's reports that look something like this. A cash flow report for an accounting system might look like that. You can have other documents that are coming out. So there's a variety of stuff that you get from user constituents that helps you do it. So here's a table of comparison that's right out of your textbook, which I thought was kind of cool, where it shows the characteristic of the analysis and the observation and the documentation analysis, right? So this is a good sort of overview. These JAD sessions are more contemporary methods of bringing people together. I think everything we do right now with the Zoom environment, these are pretty easy to do. Just schedule a Zoom, get everybody on the phone, hash out a joint session in multiple days or even multiple weeks if it's complex, and you get it done. You don't have to do anything. People aren't going anywhere anyway. It's just another Zoom call. But it's getting the right people at the right place at the right time. So I actually think the remote nature facilitates this, because when we were traveling a lot or more freely, it became expensive as well as very onerous to get everybody in the same room, because that was the expectation. Now it's the same virtual room. So I believe these JAD sessions are getting cheaper by the minute and just norm, very easily translating to norms going forward. And again, as I mentioned, this terminology was actually started by IBM in the late 70s. Structured process where everybody gets together, right? Intense meetings, less lagging conflicts, right? You work everything out together. There's a leader typically, there's users, there's managers, there's sponsors, there's IS people, and somebody takes the scribe role to document. And it works pretty well. You end up with features of a proposed system pretty quickly on a piece of paper. Like I said, this is increasingly a picture of the past. This is just a Zoom meeting, right? It can be a Zoom meeting now. Prototyping, we talked about this in great length earlier, but don't forget it's an iterative process. The key word here is iterative, and basically quick view, quick test, quick view, and moving along, making a decision on the system, and then going into full requirements analysis. And this is a pictorial version of the methodology of prototyping. I'm not going to drain this, but this is pretty much, we talked about it as we went along, I think. McConnell sort of memorialized this by way of what he called evolutionary prototyping model, right? You come up with an initial concept, you do a design, you refine it, you keep refining it, and then you complete it, right? So visually, it kind of evolves into a solution. And that's just another way of putting it, basically. Modeling is key in the McConnell method. Basically modeling after a set of business assumption. And typically, once it's built, it does its purpose. When you go to the full system, the prototype in an evolutionary system becomes the system, but oftentimes you don't do it that way, and you end up throwing away the prototype because it was only there to serve as a mock-up. So evolutionary actually builds into a production system, whereas a throwaway prototype does not, or it serves its purpose by showing a quick mock-up and enabling decision-making. And like we've discussed, this is very good when the requirements are not fully baked. Very few people are involved in the system, and there's specific requirements and lots of communication issues that are either predicted or experienced before you get everybody in a room. They built the system in short order and make decisions based on it. Business process reengineering is really a method to implement changes, often radical changes in the process that supports the business, right? So you're trying to come up with some breakthroughs to revolutionize your business, and that portion of your business, oftentimes it involves reorganizing how the data flows, achieving synergies between different steps, either in the beginning of the process, middle, or at the end of the process, and being more responsive to changing needs of the business. So this is somewhat of a system-independent exercise, but oftentimes we recommend, and clients do, BPR alongside of the system's implementation, right? And this is even more pronounced when we move to the cloud or move from an internal built solution to a new solution that's externally built or bought or leased. Then process refinements have to be made to fit into the new technology investment. And typically BPR efforts are required. In order to do BPR, you need to identify the processes that are ready or ripe for this reengineering. If there are key business processes, it makes it tricky. They could have radical change. They could be disruptive to the business. They could alter the outcomes of the business, sometimes for the better, which is why it's needed. But oftentimes it can have detrimental effects if it's not planned right. And you get a huge change management aspect where people aren't ready to accept change. They're afraid of how their job is going to change. Many jobs disappear as a result of BPR because you're simplifying and maybe allowing the system to do certain things in a more automated way, and resulting in staff savings. Companies love that. Many employees don't, because They're afraid of their own displacement. But if companies manage it right, then it's not as disruptive. Um, there are disruptive uh, technologies that often have to be implemented uh, to achieve these radical changes, right? Um, so, hmm, uh, this, sometimes these efforts are referred to as transformational or business transformation programs, initiatives, and they can be somewhat trying um, uh, to uh, to the organization. There are some rules. Information can appear in only one place at one time. Um, Distributed databases allow the sharing of information. Um, Businesses must choose between centralization and decentralization. Advanced telecommunication networks can support dynamic organizational structures, right? To support those rules. Managers must make all decisions. Decision support tools can aid non-managers. So these long-held rules are addressed by various disruptive technologies, and we've seen great results in different companies, right? For example, the sales implementation or the sales automation system I put in a couple of years ago at a client, um, you know, uh, executives did not have visibility, so they could not assist their salespeople when a deal was stuck. They would end up just losing the deal. So they decided to build in some sales automation, build in some workflow to give the executives capability to be able to see what and interact with their salespeople. They were able to do that and determine early problems in the sales cycle so that the manager could pick up the phone, talk to their sales rep, and say, hey, I'm going to help you with this. I see this is what's been happening. And in many cases, the salesperson will be surprised. Oh, wow. Sometimes unpleasantly surprised because they might think their boss is calling them out for not doing their job right. But other times, it was a pleasant surprise where the boss or some other department head or some other person across the aisle might be able to help close the deal. So, um, while simple, Salesforce automation is simple, it could be very disruptive or different and include a huge amount of change in an organization who has not implemented or embraced that kind of technology before. Um, Agile methodologies and requirements determination process is slightly different. Um, there is continual user involvement in Agile, like we discussed. So there's analysis, design, code, test. Um, this is usage centered, right? And focuses on each user and what their role is in the organization, what their goal is, and what they're going to, the tasks that they're going to do to achieve those goals. So it's very planning and execution oriented, and it has its own set of uh, you know uh, iterations or iterative cycles to get the job done, and it works quite well. And you see this analyze, design, code, test. This sometimes goes around 2 or 3 times, maybe more, to come up with the final system. And agile teams are able to do that rapidly. It tends to work for mid-size or smaller projects and not as much for the high-level complexity, large projects, because it's very difficult to do that in a unstructured or semi-unstructured way. Um, Just to touch on process requirements, right, versus system requirements, process modeling is very similar, but focuses on process steps instead of systems, right? So the diagramming is usually centered around movement of data between processes, and there's two important concepts that affect data flow and data flow diagrams: balancing and decomposing of processes. And oftentimes the result, the core deliverable is the data flow diagrams, picture movement of data between external entities and processes in the data stored within a system, right? Graphical representation. So if we look at our original delineation between determination and structuring of requirements, this falls under the structuring of requirements. There are some natural language or natural symbols delineating processes, data stores, data flow, etc. There's various, the DeMarco Jordan symbols are there, gain, sarson, there's various. I'm just trying to give you a sense of appreciation that there are specialized symbols to denote things. So this could be, for example, a small example of how customers interact with banks, right? They record a payment, they make a payment, data flows from one step to the other. The customer master is updated, and a receipt goes back to the customer, right, to complete the transaction. There's a burger food ordering system that connects the customer with the kitchen, and the management gets the appropriate reports so that they can fine-tune their business as they go along. So that kind of is what I wanted to share with you from a overall custom development methodology, as well as some focus on requirements gathering techniques. We talked about prototyping, we talked about documentation reviews, we talked about interviews, and then we also talked a little bit about the difference between system requirements and process redefinition and process re-engineering. So hopefully the session was helpful, and I encourage you to review this material again at your leisure. And until next time, I will close the session. Thank you and have a good day.